So, hello and welcome, everybody. Welcome to this third session of our um, group of webinars on new SDC Verifier. Um, I see some new people joining, so please don't be afraid of that we've already made some progress. All the sessions has been already recorded. So today we will continue to work with the model we have started to work with on previous two sessions. But recordings are available online, so you will be able to go back to that and see what's been done before. So today's session is focused on checks according to standards with SDC Verifier, and we are going to discuss how to perform certain verifications of the model that we have prepared before. Let me guide you through what we did on the previous sessions. So on the first session, we have built the FEA model, and I showed the functionality of SDC to create geometries and create mesh. On the second session, we discussed how to apply the loads, boundary conditions, how to combine those loads, and solve the model with Simcenter Nastran. And today we are continuing with the checks. Important thing is the software that I'm showing to you today is one of our new products, and we are excuse me just a second.
Yeah, I'm muting. Please mute yourself if you can't.
Yeah, and put mute on entry on Petro. Important thing to know that this the software I'm showing to you today is one of our new product, and we are offering 3 months free licenses to those who are attending this webinar. So if you're willing to do the same checks, if you're willing to try the software and you need simulation capabilities, don't hesitate to contact me via email, oleg@sdcverifier.com or support@sdcverifier.com. Let's connect on LinkedIn. You can visit our website for more information. So don't lose this opportunity to get the software for 3 months for free. And now it's time to go to the software itself. So yeah, if you just joined us for this session, you might be seeing this for the first time. But in the last two webinars, we have built this model of the tower, and we have applied some loads and boundary conditions to this and have analyzed this model. So yeah, it's a simple tower with beam and plate elements. We have introduced some offsets. We have applied some loads like gravity, vertical and side force, wind in X direction, made a pinned constraint in the legs. You can turn the constraint on over here. Yeah, and what we have done the analysis itself. So if we'll take a look on the results of this model, let's say on the, we have combined the loads also. So we have this 4 individual loads, which we have combined into 4 loading sets. And then we have 2 load groups with individual loads and load sets, and load group with load sets. We have built a stress plot to take a look, and these are the stresses in our model. Maybe I'll turn off the fillet edges. So we have some, I have adjusted the results a bit, so it looks pretty interesting. For the checks, we have some overstressed areas, just about 240 megapascals. And it's interesting to verify this model for beam member checks. That's something we're going to do today. And let's say we are going to do weld checks or fatigue analysis of this structure as well. So let's not, yeah, that's basically an introduction into what we have done. Let's now continue with verification according to rules and regulations. So we have this tower, and as I just mentioned, we want to do 2 types of checks. We want to do checks on beam members. So we need to recognize the beam members, because for beam buckling, we need to know the effective length of each and every member. And our model is beautifully meshed with a nice, decent mesh size to have precise results. So to perform recognitions with SDC Verifier or detection of the structural members, we go to Recognitions tab. And here we have different tools to define the structural members, such as joints, beam members, panels, welds, connections, and sections of the beam. And we have a nice button to recognize all and everything, which is good for quick verification, for quick find everything. But today I want to pay a bit more attention to what we are able to recognize. So we will find we will detect all the members and welds in our model. So let's start with beam members. To run the beam member finder, we click on this button over here, and we have a tool which has a certain options to detect the beam members on our model. So over the lengths in Y direction, in Z direction, and for torsional. But everything you have to do at this point is to click one button, click find. Okay, joint finder has been detected as well. So in a second, you have all the beam members detected automatically. We can see that in our model, there are 32 beam members. So we can see all of them now detected in this list for both lengths Y, lengths Z, and for torsional. We can edit them, the specific members, by nodes. So we see that this big member is split into 4 sub-members in nodes 11, 22, and 33. We can add or remove connections in this point to split them manually if necessary. That means this model is super simple, right? So everything what we wanted to have in this is included, and all the connections are here. But if it is something is not included, but it breaks your member or so it's possible to modify that through this editing tab. And also here we have a filter where we can see some of the specific members, for example, to find all the members by lengths that are bigger or equal 5 meters, let's say. We click on filter, and then here are these members filtered. So we actually have some members of 12 meters length. Another thing, what we can do here is to plot everything to see what have SDC Verifier actually recognized. So I'm clicking on this field with the recognized beam members, selecting everything with Ctrl-A, and here we have a button for plotting. So let's plot them with labels of IDs. It's a number 3 option. Clicking this, and now SDC Verifier has plotted all of the members that are recognized with the IDs of those members. So you can see here that mesh independently doesn't matter how many finite elements you have over the lengths of the this members. It has been recognized, and the forces will be summarized, so we are able to run to use it in checks. If we go back to the recognition, we can do another plotting. So we can also plot with length labels, for example, or with length factor labels and orientations and so on. So it's nice to see if the recognition is done properly, if everything has been recognized, is everything correct, is everything good in this case. So recognition is done. So now I'm plotting the members for lengths in Y direction, but the same can be done for lengths in Z direction. So everything is included in here. And that's basically everything. So what I showed to you in the last 5 minutes is how to navigate and how to use this Beam member finder, but in reality, it's super easy. You do two things. You click find and you click OK. And SDC Verifier has defined all of your Beam members, right? So now we can remove this text options and maybe again color with property colors for a nice view. So now we have calculated our model. We have some stress results, but is it okay for beam buckling, for beam member checks? Let's go to standards and let's create one of the new standards that we have. It can be done either through a model tree or through this tab on top where we have different standards available. So right click on standards, select add. You're adding standard from list or here from the menu on top. In the last release, we have added AISC, American Institute of Steel Construction, member check of 360 to version 2022. So I know that for the multiple industries, a lot of structures are still built according to AISC 89 or AISC 36010. So these standards are still available in our library and you can continue using them. But let's use the newest one today. So let's use this AISC 36022. I'm just clicking on this button and the standard wizard, as I call it, appears. So why do we need this wizard? Because SDC Verifier is automating a lot. We are able to read the results. We are able to read the property parameters or the model parameters to run the checks, but we still need a human being engineer to make the decisions and to do the checks. So there are a couple of options that has to be defined. First of all, you can select the method. Is it ASD or LRFD? Secondly, you need to define the section build-up type, and that's basically the only decision to make here. So we're clicking on this, and for every property, we can assign, is it rolled or is it build up? So we say it's rolled and select apply to all. Now, all of the properties that we have in our model that we have created before, we are defining them as rolled. Then we can define the CB factor. What is also nice in SDC Verifier that for everything you have an explanation in help. So if you click F1 here, you are getting the help page open and AISC 36022 member check, where each and every method is explained for resistance factors difference, the every functionality, so what does change if we select rolled or build up section, user defined CB factor, and so on. So for each and every factor here, we have an explanation and reference to a standard. So I'm not going to go through each and every options able to define here. Anyway, they are automatically defined. The stiffener distance is taken from the beam member recognition tool. So if inside of your section or beam you have some cans or stiffeners, you are able to reduce the effective lengths with this stiffener distance category. On the right here, we have a selection where it is possible to define a portion of model to be verified. As you can see, we have 17 shapes supported for this. We have 17 shapes in total in the software. No, 17 of them are supported. So rectangular bars, tubes, circular bars, I-beams, channels, boxes, some Nastran sections are supported. And you can, so now everything what is supported is included, so all kind of beam properties. But if you want to do a calculation on some specific selection, it is possible to do it via our rule-based selector. So on a specific type of element or materials or group of element, component, and so on, it is possible to do the check for limited amount of selection. As an experienced engineers, you might know that AISC 36010 is cross-referenced with API RP2A with for tubular members. So you can define this, select this checkbox, and for tubular members to create API standard, to define the buckling of tubular members via this option. Let's exclude this for now, not to overcomplicate this analysis, but it's good to know that it is possible. And SDC Verifier uses material yield and tensile strengths for calculations, but it is defined in the project, but you can adjust here, or if it's undefined, you can set the parameters for yield stress and tensile strengths. Second order effects, if you would want to include it, again, it is possible to take it into account or include a torsion check. Again, everything is explained within a help page. So the torsion check is covered over here as well. So don't hesitate to, if you're willing to learn more about the code or about anything in SDC Verifier, it is in the help section. And what is also convenient in this standard creation menu is this button where we can define settings automatically via one click. So if you it is possible to store the settings that we have just defined by default to the library and then always load them by clicking this one button. I'm not going to do this at the moment, but for big standards with a lot of characteristics to define, it is a significant time saver. So yeah, that's it. Basically, we just define the method, the resistance factors, either LRFD or allowable stress design method, ASD, and build type of section. Is it rolled or is it built up? We press OK, and the standard has been created. So over here, you see that standard is added. And what is, I think, one of the main benefits and positive points in SDC Verifier software is the fact that the checks are open. Checks are not a black box. It's not like your model is okay or your model is not okay. We are showing all the calculation procedure and all the formulas to our users. So if you would open this, so in the model tree, if you click on this check, you open it and you see that AISC 36022 consists of 16 different checks and one overall in the end. And you can do whatever you want to, you can open whatever check you want. So axial strengths, for example, you click on edit and you see the calculation. So every parameter, maybe I'll make it slightly bigger so you can see it. Every parameter, every formula is having a description. So from which formula in the standard it is taken, from which equation it is taken, from which table do you need to take the data, and what is calculated in the end. And these formulas are also open to be edited. Of course, you cannot edit AISC 36010, but if you convert this to custom, so you can see here, it's built in, not editable, and you see that edit button is not available. But if you convert it to custom, it won't be called AISC anymore, but you can call it my personal rules based on AISC standard, and you can modify the formulas. So, or write your own. So for any standard, let's say axial strengths, we are checking here. For any standards, if you think that something has to be adjusted, extra safety factors introduced, or you just want to make your custom check, SDC Verifier allows you to build these checks either based on the other rules or to start completely from scratch. You click on custom and you start building your own standard. So in our library, we have 38 different standards, and it's always it's always expanding. We're always adding more. But if you're missing something, you can either ask us to implement it for you or to create the standards yourself. Okay, so what we want to do is to preview the results of this checks right now. So we go to overall check, and here is two things we have already automatically generated. One is the plot on load group of all load sets generated. So we click on preview, and SDC Verifier starts calculating the check in this moment. Calculation time depends on how big is your model and how powerful is your computer, but you can see for the simple model, it is literally 2158 up till the calculation has started, maybe 58. 2151, it's 7-second calculation time for this model. So it's instant. And SDC Verifier displays the utilization factor. So if I click on editing this plot, you can select here, what do you want to show? Either utilization factor for axial, bending, or combined, or overall. So we are now displaying overall, but if we want to display axial, you can press OK. You can also update the title, click on preview, and we can see that for axial force, everything is fine in these members. But if we do the overall, and we click on preview, some members on top here are not passing the checks. So this is the way to present the results with plots, which shows that utilization factor is about 1 for a certain area, but we want more details. So we have tables. And one of the table over load groups is automatically generated already. So I can click edit on this. So what do we have is selected loads is 2 load groups that we have here. And on full selection, we have results table here. So to see this, we click on field table, and we see what actually is causing a problem. So axial force is okay, but bending for load sets is a problem. And then combined axial and bending is causing even bigger problem. If we want to have more understanding what's happening with our model, we can add more loads. So include all individual loads and all load sets. Press on OK and press fill table. And now we see everything. So gravity is not a problem for our model. Utilization factors are close to 0, which is reasonable. But vertical force for axial and for bending and for shear is okay, but combined axial and bending is already a problem. Side force is not a problem at all, and wind is not a problem at all. So vertical force is something that is causing buckling problems for our to our model. And then if the loads are combined, so in load set 1 and 3, we have this vertical force included. So that's why it is causing the same overshoots as in individual loads, and you can see it in load groups. If you have this table huge with hundreds of loads and thousands of combinations, you can always filter either by name or by results. So for example, I want to filter everything where overall utilization factor is more than 1 or between, let's say, between 1 and 2. And then I click on filter, and only results that are not passing the check are filtered. So vertical force is the individual load that is causing a problem, and since it's included in load sets and load groups, it's causing a problem there as well. So these tables in SDC, we have like 6 different types of tables, and these tables are extremely convenient to understand the behavior of your model, and not just. So what I'm always trying to explain, that your model is, or your FEA result is not just red is bad and blue is good. It's one of the common mistakes that junior engineers are making, but it's not enough to understand why you have this problem. So you need to study and see, okay, what is the problem in this case is the vertical force, and it's causing problems for, let's clear the filter. It's causing the problems for combined axial and bending in case of vertical force. So this is how you do the beam member checks with SDC Verifier according to AISC. And one more standard I want to show to you today. So I'll save this, press OK. Right. One more thing I want to show to you today is fatigue checks. So to run the fatigue checks, we need to define a couple of things. First, let's show full model. Model groups. Yeah, let's just do a plot with everything. So back to our stresses, we'll see if we have any stresses in plates. Preview. It is here, but how do I show the plates? One. Here it is. Okay, texts are off and results are for everything. Preview. That's this. I'm plotting the utilization factors, and I wanted to plot the stresses for load group. Preview. Everything is included. So back to our full model to see that we have some stresses due to side load here in this side plate. So we want to do a fatigue check. As you may know, fatigue are mostly prone to occur on welds. So we will need to detect the welds in our model. But first, I want us to create the fatigue groups to define the amount of cycles for fatigue. So we go back to jobs. We have a couple of individual loads, load sets, and load groups, but I want to define the amount of cycles for these groups. So I will create two more groups. I will click on load groups and add. And I will create one group of vertical force, which we know is causing problems. So let's say it's vertical only, but gravity is, vertical only. We know the gravity, yeah, we need gravity all the time. So gravity and individual load vertical force. We press OK. And then I create another load group, which I would call side force. So gravity and side force, and call it side only. And I'm pressing OK. So these are the two loading cycles that are going to happen in our fatigue analysis. Now I need to create fatigue group. So I click on fatigue groups, select add, and I'm defining vertical only and side only. And let's say I would want us to have 200,000 cycles of vertical load and let's say 50,000 cycles of the side loads. I have defined the amount of cycles and I will call it fatigue 250K, for example. Total amount of cycles is automatically calculated and displayed here for your convenience. I'm pressing OK, and fatigue group of 250,000 cycles has been created. Now let's do the check of Eurocode fatigue. So I'm clicking on Eurocode here. And as you can see, we have a lot of different types of checks. So we have members, welds, fatigue, bolts, fire design, protection, plate buckling, and connections. We are interested in fatigue here. So I'm clicking on this. And again, the standard wizard is appearing. So we can press on F1 and the help for Eurocode fatigue is defined. The extremely important parameter or option to define for fatigue is FAT class. So FAT class is the fatigue strength for nominal stress range, and it's represented by SN-SURF. So all of our fatigue checks are based on Palmgren minor rule or SN-SURF method. So by defining the FAT class or weld class or weld type, I think it's called in certain standards, we are defining the SN-SURF, which defines the fatigue strength. So for Eurocode, it is pretty simple. Again, there is an explanation in help, but I will do a quick one setup with you. So I'm clicking on this FAT class, and we will say, so here is this FAT class value. So for full model, we need to define the value. So let's say it's going to be, it's non-welded, so it's 160. Apply. But sorry, I was a bit too fast. We started doing the classifications, but we haven't recognized the welds yet. We can either do it from weld. Yeah, let's do that. So I jumped the action a bit. I'll cancel this. So in the same way, in the very same way as we have recognitions of beams, we have recognition of welds. So we click on this button, weld finder. Welds in my model are already recognized. I did this probably yesterday. So I'll remove all of them just to show you how quick and easy it is to find them. I'll just remove them. Basically, the logic is completely the same as with all other recognition tools in SDC Verifier. All you have to do to detect the welds is press one button, find. You're clicking these buttons, and within, I would say that for 1 million finite element model, it takes less than a minute to recognize all welds. In our model, it's just 3,000 finite elements, so it's instant. Here you can define select the welds. Again, you can plot them all. We'll do that later on. You can define the weld stress options, strengths options. So for every weld part, you can define the parameters. Is it full penetration, partial penetration, fillet weld, and so on. And you can define the settings for hotspot stresses if you want to use a hotspot stress method in your calculation and mesh is fine enough. You can define the reference points formulas for weld strengths, for hotspot stress method. But back in the welds, if we select all of them and click on preview, SDC Verifier will highlight the elements that are recognized as welds. So by the weld, we are recognizing all the property change, material change, thickness change, and connection of a certain angle as welded elements. So as you can see here, all the welds has been recognized. And now we can run the classification for fatigues. Sorry, I jumped a bit too fast to standard. First, we did the recognition. I'll go back to this recognition tool and press OK. Yes. And what we do next, we are creating the standard. So I go to standards, I select Eurocode fatigue, and we are back to this FAT class definition. So in this window, first we are defining FAT class, and for full model, it's going to be 160. What is important to understand here is that what is important here is to have a possibility to that every next rule is overwriting the previous one. So full model is 160, but now we need to define welds. I'm adding new condition, and in this new condition, I'm selecting, okay, all welds for the direction in. So I clicked on none, multiple condition we can also define, but one condition, everything is already defined. And all the welds along the weld are going to be 100, let's say 100. Pressing OK. So full model is 160, but all welds are 100. New condition, all welds, none, but perpendicular to the weld. And perpendicular to the weld, we can do 90, because it's a bit lower. And for shear, we need to define, we can also copy this condition and here select 90, or select the value and say 71 for shears. We need multiple shears. So we do create new condition, add all welds for XY shear, 71 for shear. Okay. And also one more conditions we can define intersections. All weld intersections in some way it's always perpendicular. So we can say, okay, all the weld intersections in all directions are always 71 as well, for example, the lower one. So classification has been defined, and again, every next rule is overriding the previous. So even though I defined the full model 160, all the welds will be 100, but the weld intersections will be 71. You can plot and preview this. We are a bit short on time, so I'm not going to show this today, but it is possible to do. What I wanted to remind you once again that if you click F1, these classifications are explained, and for every standard, the FAT classes and SN serves that you are defining are shown. So over here, you have the description and explanation of FAT classes. Okay, when we have defined the FAT class, we either need to define the size effect and reduced range. You don't even need to click on help. There is a small tooltip explaining what is this. Size effect is coming from chapter 722, and it's given in tables 1.1, 8.1 and 8.10 of Eurocode 3. And the last thing we have to define is two parameters, consequence of failure and assessment method. If we are raising the consequence of failure, there are only two options, high or low, and assessment method, damage tolerant to safe life. Our safety factor gamma MF is changing. So it's 135 for high consequence of failure and safe life, or damage tolerant and low, it's 1. If it's high, it's 115, so on. So let's be as safe as possible, high consequence of failure, and safe life assessment method. We're selecting this. And the last thing here, yeah, I showed you before that it is possible to define the hotspot stress method reference points. If you want to use hotspot stresses in fatigue, you just select this button and the hotspot stresses will be used in the locations which are defined in Weld Finder tool and which are having suitable mesh for hotspot stress. But let's skip for now and press OK. And when we have done this, the classification has been set and we need to calculate fatigue in our checks. We have nominal check, fatigue check, and overshoots of for fatigue. Again, you can click on edit and see a complete calculation procedure. So what is defined, how is that calculated? You can see that we have a sum damage for fatigue, and we also have damage root 3 and damage root 5 to estimate M equal to 3 or equal to 5, the slope of SN serve. And yeah, again, it's open, it's visible, it can be included in the calculation report to show to your customers how did you do this calculation. So no secrets at all, and it's nice to understand what's happening in the background. Okay, so let's do a plot for fatigue. For B members, we already had something automatically defined. For fatigue check here, we are going to click on fatigue check and create criteria plot, let's say, or contour. Let's do a contour plot. We have some plates. Few things to define. Again, selector, as you can see, this rule-based selector, it goes through the full program. You can define how a portion of model to analyze, portion of model for checking, for recognition, for plotting, and so on. This selector is very powerful and a nice feature and tool to do the checks within, to select the portions of model for the analysis or for whatever you do. Here you are able to select the fatigue group, since we only have one, which we just created with you a couple of minutes ago. We have this 250K. We select this, and parameter, do we want to have a summon damage or damage with root 3 and root 5 to take into account M equal to 3 or to 5. By default, it's damage root 5 with a default view, and that's okay. I'm clicking on OK, sorry, and the plot has been created. So now when I will click on this and click on preview, SDC Verifier will start running the check. Again, depending on your model and computer calculation time may differ, but it's always a matter of short periods of time, of minutes, I would say. So we can see that some of the corners might be having a little bit of higher value in utilization factor, and this zone, due to 50,000 cycles of side load, is just okay. But this connection over here is something that is having utilization factor of 1.1, so it's an orange color, so it's between 1 and 1.1, which means we are just above the safe value for fatigue damage in this specific case, in this specific location. And we remember that this was not passing the member check anyway. So either the load is too high or this supports at the bottom has to be modified. It could be modified via SDC Verifier optimization tool. Maybe we will show this in next session, or you can go manually to your model. So back to what we did in the first session. We are in our model and the properties where we have this I-beam 200. We can click on edit of the shape of this I-beam and maybe work on the adjustments to pick the better shape to pass the requirements of AISC for beam buckling and to pass the requirements of Eurocode fatigue strengths. That's everything I wanted to show to you today. So just two more final points from me. First of all, it's a third session of 4 that we have done. So we prepared the model, we analyzed the model with Nastran, and in this session we did Eurocode and AISC checks according to standards for beam buckling and for fatigue. And in the next session, we are going to go with you through the result presentation tools, reporting tools, and maybe I'll try to fit optimization. So to make, because the goal of an engineer is not only to know what is a result according to a specific standard or is your model okay or not, but also to make sure that your model is okay. So I hope next time in next session we will have time to run through some design optimization for this and then preparing the report, and I will show you the advanced levels of the advanced tools for presentation of your results. And the last thing is I'm mentioning again that the software you see at the moment is available for free evaluation license for 3 months. So if you're willing to try this software or to use it for your routines, don't hesitate to contact us after this webinar. Please send me an email at oleg@sdcverifier.com to get a free license, or to send us an email to support@sdcverifier.com. If you have any technical questions, let's connect on LinkedIn. Always happy to communicate through there. And in case of any questions, you can contact us via the sources you see on this slide now. And if you have any questions right now, I still have a couple of minutes to answer those questions.